we get process signals and dynamic signals. So now we have our data acquisition place physically. So on the control level, we have our predefined monitoring parameters and the operating mode identification, followed by adaptive threshold monitoring. So then it'll always check for the manual or cyclic or event-based triggering. So based on that, it creates a CMS file and push the file to your central database or for the further analysis. And in terms of cloud connectivity for such applications for the long term, so whereby that we have developed the adaptive cloud system. It's a one-click, the entire measurement system published on the cloud, as long as we have a internet connection via 4G or 3G or 5G or Wi-Fi. And also on top of that, we have given a comprehensive user interface plus applications with state-of-the-art APIs. And here, when it comes to the security, it always enables with the peer-to-peer connection. So the digital signature is there, so whereby that you can access for your own data from anywhere in the world. So everything in summary, any type of a sensor data streaming into a DAQ, you can either publish into any cloud, or you can push it into a Gantner cloud, or again, if you're not using any cloud-based applications, then again, you can put it into your own server system. And even in terms of data visualization or running your own formulas or mathematics, still you can develop by your own Python, LabVIEW, MATLAB, or you can stream with other applications. And it is purely customizable, open source, easy to use. And the building blocks for the own databases or the dashboards, in simply, you can get the entire analytics, APIs, user interfaces with distributed streaming platforms on the databases. So despite the sensor type, despite the hardware, all works as the same, and it is scalable. And moving forward for the points to consider, that when you have a concern, any concerns about how you can create the traceable data logging, this is one of the solutions. And harmonized processing with different sample intervals for different sensor types, again, it can fulfill the requirements. And real-time operating with the multiple data streaming or multiple data processing systems. Or you can connect with AI or ML and digital twin to a one system, plus open protocols. And in summary, this is how the entire connectivity works for the sensor systems, IOs, to controllers, and multiple data streamings for local Profinet, Modbus, or CAN or GI data, and multiple manufacturers who are giving their own data, multiple data streaming to dedicated cloud-based platforms or server platforms. And earlier we have discussed on the how to configure or some samples of the FFT processors and the IO modules. But in simply, that you can develop it as your own plugin and just upload the plugin to the controller. It'll work, it'll debug by its own and start processing according to your plugin application. So these are all open source applications. So the moment we move forward for the how we have adapt this into the real-time applications or the real-world applications, I have selected the quite prominent ones out of what we have done. So this is one of the test validation application we have applied in Italy for the Vibrastic. So hereby, they want to do the NVH validation lab. So we have done the sound power measurement for the equipment validation. And again, how we have used expandable 4-channel portable systems with multiple ICP and IEP sensors. And again, we have used a similar application on the bearing vibration and temperature testing in China. So the market of aerospace, hereby, when the satellites been, these applications been used in the vacuum environment, for the vibration and temperature testing of the special bearings. And these special bearings are used in the satellites. So it is quite necessary to simulate in the vacuum environment. So hereby, you can see in the certain images that the portable systems being used, real-time collect data, process, and publish the data for their further analysis, and certain algorithms being running locally. And on top of that, here one of the exciting application I have done in with the Jurong port in Singapore. This particular cement unloader have three bearing types, and the challenge is that we are unable to put up a typical vibration or the accelerometer mount on the bearing housing, because the entire cement flows through. So there's no provisions for us to run any cables or even for the wireless sensors. So here what we have done, we have used near field microphone systems to capture the data. So in terms of internal, the bearing side, there are 54 pellets. And if a one or two, you can see that shaft being exposed, these inserts being dropped out. So they want to identify one or two being dropped out, then they want to go for a maintenance cycle. Because removing, repairing will take, it is taking more than 16 hours. And most of the ships won't take that time. So here, one of the preliminary microphone data that we have been accessed. We have done the feasibility and the prototype in the first phase for the non-contact sensing system for the condition monitoring for the screw unloader. And here we have used two independent systems to collect the data from grass microphones and customize software and publish the data and push data to their mainframe. So the system works purely independent. And another application we have used for all type of sensors here, remote bridge monitoring application, strain, vibration, displacement, and temperature. So here, the independent devices without a server running at the outdoor facility and push data to our cloud. And this particular cloud belongs to the end user, and it is a third-party cloud that they are extracting the data and calculating the prediction based on the day and the time and the traffic levels. And furthermore, on the bearing validation or the QC testing for the Schaeffler Group, the worldwide that we have been developed for them test benches for them to do the validation for the bearings and automotive and transport. So in terms of automotive and transport, standard engine test benches, brake, vehicle dynamics, and gearbox systems, drivetrain, powertrain systems, enormous type of testing applications that we've been working on with mostly like with the system integrators or directly with the end users. And some of the R&D applications into the place on the noise, vibration, temperature, especially with the A-Star here and Alstom for the railway testing for the downtown line, circle line, under the tunnels and the deep tunnel swage systems. Plus, one of the companies belongs to, two of these companies are in Indonesia. One is the Niri Rubber, PT Samudera. We have developed them remote rubber compression testing test bench for them to reduce their time for the product QC, and Clatec in Batam for the deep sea pipe bending test. And there are many more other companies, and I have selected the quite interesting and the large channel counts ones here. And on top of the typical industry applications, we are quite prominently applying in aerospace, especially in terms of performances monitoring. We are taking accelerometer data, strain data, or the microphone data into account of the behaviors of the aircraft assembly during the wind tunnel performances monitoring, then air pavements or launching pad health monitoring, UAVs controls. So one of the samples here we have used for in aerospace, this is one of the world's largest outdoor aircraft engine testing facility by Safran. And for the Ariana group, for the Ariane 6 payload fairing for the separate test we have applied in space, and UAVs for the Lockheed Martin. And certain applications we have embedded. We have customized our hardware and embedded inside the devices with the moving applications. And wind turbines. So this is one of the key areas that we have been doing with the DNV GL and TUV Rheinland for the wind turbine health measurement systems. So these are purely remote health monitoring for and predictive maintenance cycles given for the wind turbine owners. And out of all these applications we have done, so we pushed that data into our internal controllers, and certain applications we let the controllers to run our AI or ML algorithms inside the controller. The one freedom was given that we are capable of expand its internal performances and run your own plugins or applications internally. So whereby this is one of the outdoor testing facility in Arizona, which we have developed as a test bench, and one in Arizona, one in Cyprus. So we continuously collecting the data. So the Arizona one is for past 8 years. We've been collecting the data. So we are identifying the missing erroneous data, correction of this data, and then again the degeneration rates, health state detectors, and the failure diagnosis. So this pattern was running inside our the specified cloud platform, and some of them running on our edge devices. And moving forward for the digital twin of assets, and here I have taken photovoltaic plant as an example that we have in terms of the variables of the day and a clear day, how the performances of the prediction of each single component, and what are the reasons and magnitudes for any faults and underperformances can be easily found in this particular application. And this is what we can get into the suggestions level or the predictions or the performances levels. Predetermination come up to a good agreement of 2.5% accuracy. So that's pretty decent for the PV side. And all these application into the business owner's perspective. We have done deemed energy calculation for hydropower plants. This application was for Africa, Uganda. And here we are monitoring, over there we are monitoring hydropower plants, penstock, spillway, and the turbines, inlet, the water power, water pressure, water levels, plus the turbine performances and the power generations. And the efficiency, deemed energy, and how much money that they have been generated from that particular power plant. And this particular, the cloud platform is interconnected with the Uganda government energy department, whereby that they also can calculate in a rainy season or in a rainy day, what kind of a water level or the water being without using just flown to the spillway, and how could that be calculated in terms of money or in terms of energy that they have lost. So in summary, in terms of putting the condition or the asset, the monitoring, what we have discussed in the past, is simply we have been taking into all the aspects or the rotary, motor bearings, gearboxes, pump or piping level, all type of potential data sources or the failure sources into count, and planning on predictive maintenance, whereby that we can save more cost as much as possible. So ultimately, coming to this particular portion that whereby that we are applying all type of new technologies, data analytics, and distributed architectures and high-speed data rates to collect data as much as possible to prevent and protect the asset. So in the entire summary of my presentation for the slide on the focus, so there are certain tangibles user benefit for the fast ROIs. So in terms of noise measurement, in terms of vibration measurement, strain, temperature, any type of sensor measurements. So on the DAQ level, so all traditional sensors or the typical voltage or current type sensors into develop the DAQ adjoining with all the industrial 4.0 applications. Real-time core works inside the DAQ and all the app connect for embedded computing, readily available and developments, plus software architectures. And it's enabled with the microservice based on Dockers. So if someone says that, okay, if the software cost X number of $1,000, they can freely develop their own application. And it is distributed scalable solution for data processing and storage. It can store locally, and if something goes wrong with the particular network, the device starts storing entire data into its own internal database. Once the network been established, it will perform the first in, first out and publish, subscribe, DDS or MQTT, and for the IoT world. Then in terms of platform, it can be Gantner Cloud or GI Bench with APIs, or it can be further solutions with the data processing. And also it can have it can have the time series data, event-based data up to 100,000 values per second. So that's quite a high data rate. And as a service, all the cases for the apply in civil engineering, automotive, aerospace, energy, and predictive maintenance with machine learning and AI. And it also can create a certain business model for different user experiences or different R&D projects or new OEMs, or even for a new ecosystem. So ultimately, this is what we bring to the table for test and measurement world by Gantner Instruments. And there are some more slides actually I have put into the appendix whenever the question comes, that I can show more applications on how we have achieved. Any questions, Mr. Ruri?
Yeah, many thanks, Mahesh, for your presentations. And I would like to invite the attendees from the floor if there are any questions. If there is any question to Mahesh for his presentation. I think we still have like 15-minute Q&A sessions, so we still have a lot of time.
Yeah.
So probably I would like to ask like just a minor concern.
Yes.
That here Gantner develop systems that use cloud computing or something like that, and I think the company shall be aware with the data security, because we use like cloud computing, something like that. And how the company address this issue anyway? Because
Right.
this is kind of issue that when I run a project in Germany, this is also a big issue that people really hesitate to use cloud computing because of the data security. So how the company address this issue?
You're 100% correct. I would say like 90% of the regional applications, their major concern is like if your cloud in somewhere else, how we can assure our data, and how we have addressed that. You may have noticed that our Gantner hardware, that the moment you collect the data, it can be the one key thing is actually that I need to address this one. The cost of the ownership is 100% with the end user. So what I mean by the cost of the ownership, he or she or the industry or the typical the company can manipulate or can include the device into their internal backend system or their internal security systems. For an example, when I did the asset monitoring for the SMRT, this is the major question, that what kind of a security level that we provide in terms of data. So when we did 300 accelerometers, when we installed in the railway tracks and as given assets, what we did, um, number one, the device IP and the device the data is within the company's the IT infrastructure. So if someone wants to access into the device, they need to first of all penetrate to the corporate network layer, break, and then access to the device. So such applications, we do not use cloud computing.
Okay.
Or we don't use cloud. What we do is we bring the cloud to their doorstep as a service, which means we put the entire servers at their facility.
Yeah.
So whereby where they want to run their own arithmetics formulas, they can give the much load to the software level. But the beauty of the hardware that they can distribute that load to both hardware and the software level. And once they include the devices into their own network, it behaves according to their terms and conditions. So typically our address or our approach, there's no way that we keep or we let the data to stream to a third-party cloud or even to our cloud if without the consent of the client in terms of security. And on top of that, if somebody wants to access to the device can be have a hard password, and also it can be hard coded. So there are so many other ways. But usually when we deliver a system, the key point, the cost of the ownership.
Yeah.
So the moment it connected, it's under their network system.
All right. Thanks for the explanations, Mahesh. And then I would like to also invite again the floor if there is any question. Yes, someone is raising hand. I have another question then.
Okay.
I saw part of your work that you show there is like monitoring systems in PP performance.
Yes.
Right. And there you say that you can also build a model to predict a failure of the system or something like that, right?
Yes.
Is this already implemented or?
It has been implemented.
Okay, so because this is, yeah, I mean it's interesting. I mean, like if you also, I mean, like your company also offers like there is machine learning embedded in this in the device or instruments that you build, and then I'm curious how the market responds to your
right.
latest development.
How we apply on this one that mostly of our applications, we work with the consultants and the EPC for the PV applications. So whereby we recommend and also we go with the string monitoring applications. So in terms of the world market, we have been occupied more than 75% of the PV industry. And the other key thing what we do is we welcome OEM. So the reason why we welcome OEM, all the patents or everything inside the hardware.
Okay.
So and also that's the main reason that we keep our hardware open source also.
Okay, that's great.
Like say for an example, PT Samudera, Lucas in Chirabon. So in 2014, they had a problem that they are one of the key the fender manufacturers in Indonesia for Netherlands. So it's quite a good things that they are doing. So they have few mechatronics engineers, and they had a problem that whenever they develop a batch and they want to get it tested, so they need to wait until the testing facility arrives to Cirebon, and then if something goes wrong with the batch, they have to discard the batch. So it's a loss of
Yeah,
money.
lots of
So
money. That's right.
yeah, a lot of money. So then they have, according to them, and they have tried to have a system whereby that they can get what they want. But unfortunately, their complaint was like, even though we can buy the system outside, but still every year we need to pay a certain fee as a software maintenance. Then one of the guys, he flew all the way to Singapore, and then he was like, he want to get a, first of all, the 36 channel system. Then we all flew back to Cirebon, and then we assessed the system. And when we developed the system, right now, it was decentralized, IO modules directly placed inside the DIN rail in their own cabinet, so no additional items. Typical sensors they have been using, tap into those sensors, and off-the-market wireless dongles, connect all the data to their main the conference room, so their clients can come. Each and every test, they can see perfectly the Young's modulus and the report generation. And 2016, we have expanded the systems with their pressure measurement. Then they have auto enclaves measurement for the product quality and the product oven applications, and the machine failure predictions. So the entire application or the software built by themselves with help of, I think, if I'm not wrong, the University of Technology Bandung.
Yeah.
So they had some kind of a government grant or kind of industrial collaboration with the local industry. So that's how they have done it. Those students, R&D team, they have done a wonderful job. So it is quite feasible for them in terms of application. So the similar token, what they want to do is they want to bring it as a product. So we have given our the consent. You can name it whatever you like, and now the product they have changed the name. It doesn't matter because
Yeah,
whenever
yeah.
they ask us to configure or whenever they ask us to customize it, we customize it. Yeah.
Okay. Okay, Mahesh. I think. Okay. I'm happy now.
Yeah. Okay.
There is one question from the floor finally.
Okay.
I think there is one question from. It's supposed Miss Ria. Can you elaborate more about non-contact monitoring system?
Yes.
I mean, in regard to your
yes.
events that you have.
On this one, you can see the yellow color, the screw unloader to unload cement coming into the country. So there are 3 screw unloaders, and these screw unloaders, they have a quite a big problem that they are facing. They have 3 bearing slots here, and these bearings are prone to fail quite rapidly because of the humidity of the cement and the powder. So if the weather conditions being changed, the pressure being changed, you can see on this next picture that the cement powder get clogged, and then it affect the bearing and the structure. And the second foremost thing, in a typical application, yes, we can keep an accelerometer to measure the bearing vibration. That is straightforward. But unfortunately, there's no way that we can put a wireless or even a wired sensor very closer to the bearing housing, because this bearing housing is inside the screw unloader, not outside. That's another problem. So then what we did, but one of the technicians, he's quite a experienced technician. He was like, he always uses his ear to listen whenever he operates the machine and says like, right now it is time to change the bearing. So we were quite surprised why and how he's been predicting that. Then we found out that there are certain pellets inside this screw terminals, and there are 54 units of them. If they start falling, if they fall more than 10, it's going to jam the entire bearing internally. So then we collaborate with ASTA, Agency for Science and Research, Then we went over. Then we had to take continuously data for a number of days and time during the operation time. Um, we have used a near field microphone system in a good screw unloader and a problematic screw unloader. Then we try to differentiate between where we are looking the changes of the patterns.
Yeah.
Then what we did, we can't use the typical scissor lift and climb up and use it. So then we come up with a little mechanical structure next to the screw unloader, mount all the microphones, run a one IP signal, and keep the devices and push the data based on the triggered. We use the trigger the data, and each and every event we have recorded and push the data to the our server. Then from there we started analyzing.
Yeah.
Then we have collected entire raw data and the event-based or triggered data. So this is where that we have apply the theory into practice, and the customized software was built based on a couple of Python Dockers, some FFT plugins was running inside, and the A-Star developed their own software for this.
Okay.
And another application, what we did on a CNC machine system, whereby that the CNC machine manufacturer claimed that they want to, when they experience the spindle, the moment it hit with the working piece, it starts chipping it off. And then the next problem was that the moment we try to keep an accelerometer on the vicinity, again, it according to them, it was a kind of a noise plus a vibration that they're experiencing. So this was with ITE. Then again, we have used a grass microphone and three-axis accelerometer side by side to compare the vibrational levels and what are the exact causes being propagating through the application process. And on the
Okay.
other hand, actually, since the question was the non-contact condition-based monitoring application, one was with one of the gearbox manufacturers in Indonesia, Cikarang. They typically use ear and just handheld noise, typical noise meters. And because it was a very old system and they want to upgrade the system. And then again, what we did, we kept the multiple microphone systems and extract the data, and the real time we let them hear, plus the crackling and the rattling sound inside whenever they do the gear changes inside.
Okay. Mahesh, there is a follow-up questions from the same person. Is there a standard for the measurement procedure using this system that that the Gantner developed, or probably has Gantner developed such standard procedures for these non-contact measurements, and is there any, for example, is there any minimum distance for the microphones to be installed in the system?
Right, good question. What we have used as a standard was the standard for the minimum distance determined by the microphone manufacturer.
Okay.
Yeah, for an example, the similar application we have used, but this is for military, for the far field, the microphone system to detect drones. And so they run the algorithm internally. So the same way, the manufacturer predict, or manufacturer gives, if you use my sensors, my microphones, or anything, this is the effective range that you can use. So based on that, we have to adhere to that application. This is the standard that we have used. And within that standard, the parameter, of course, yes, we have adjusted the certain distances and blockages, and we try to get the best data out of during the installation. So for the first, what we did before we go for the permanent fixing of the structure, we have used a handheld device, and then we try to see where the sweet spot to generate to acquire this data. So lucky in this application, the facility had some baseline data. They were using a handheld device.
Great. Okay, thanks for the answer. And
thank you.
I guess we still have 10 minutes around left. Then I would like to invite again the floor to ask questions to Mahesh. No? Then if this is not the case, then many thanks to Mahesh for your presentations. It was really insightful and informative about the recent development for noise and vibrations measurements, especially in Gantner instruments. So yeah, many thanks.
Thank you very much, Yuri. And again, thank you for the entire committee, with especially for the Dr. Ivan for introducing. Yeah.
Okay, so yeah, as we already finished these plenary talks, so I would hand back these sessions to the Master of Ceremony for of the ANV 2020. So many thanks for your kind attention. So yeah.
Thank you very much.
Please enjoy the rest of this conference. So
thank you.
It's nice to meet you, Mahesh. So
pleasure meeting you. Take care.
So so the committee, is there any the committee here? Mbak Mas, so
okay, sir, I'm here.
Yeah, so shall we leave the breakout room or shall we stay here for the next sessions?
Okay, the next session will be another plenary room. Please go to the plenary room first, and then we will go to parallel room at 14:57.
14:50.
Yes.
Okay.
Yeah. For now, we can go to the main room first.
Okay. So I have completed my duty. So I just want to ask to leave this room, and yeah, thanks for the committee for organizing this. So I will leave the room. So
thank you very much, Mr. Ruri.
okay.
Thank you for our moderator in this session, Dr. Uri Agung Wayuwono and Dr. Dani Arifianto. And also, thank you very much for Mr. Mahesh Kavinda, the Director of Gantner Instrument South Asia, and Professor Valtteri Hongisto from Turku University of Applied Science for such outstanding presentation, and for all the attendees for the discussion. Moving on, ladies and gentlemen, now we would like to inform for all the participants, you may join the parallel session, which will be conducted for 2 separate rooms. But before we start the parallel session, we have hope to all the participants to kindly stay at the event until at the end of agenda, because there will be announcement awards for the best paper and presentation. That's all from me. Now, you may join to the breakout room, and we will see you again after the parallel session. See you later.